So today's main objective is to talk about the chain rule. It helps us in taking derivatives of more complicated functions where you have a function within another function. Looking at like the sine of 2x has an inside function of timesing by 2 and an outside function of taking the sine of whatever the input is. So we're going to go ahead and explore a couple things in your calculator first. So go to your y equals, type in the sine of 2x, making sure you're also in the radian mode. And then we're going to have the calculator graph your derivative. So you're going to have to go ahead and go down to y2. You're going to select math, go down to nderiv. It should display something like this. And then you'll have to go ahead and arrow over where the y1 is, and you'll have to get that put in there. And remember, you need to hit vars, arrow over to y vars, and then select y1. Then you're going to want to arrow over here to right underneath the cursor where there's a blank box and put in x. So once again, your nderiv is your eighth one down underneath math. So when you graph it, I would go ahead and hit zoom, top center button, and hit trig. It should display something like this, where your original sine graph is here in blue. And we know the derivative of sine is cosine, but you'll notice it's just not a normal cosine. It's got an amplitude of 2. So in other words, your derivative of sine of 2x is really not just cosine of 2x, it's being multiplied by 2. So it's a 2 cosine of 2x for your derivative. So what's the deal with that extra 2 in front? Well, it really comes from the derivative of the inside. So the chain rule says we do the derivative of the outside. The derivative of sine is cosine. Doing nothing to the inside, keeping it as is. Now we got to multiply the derivative of the outside times the derivative of the inside. Derivative of 2x is just a 2. So that's the chain rule. And by the way, we're multiplying here, so we can multiply in any order. I just chose to put the 2 in front. So that extra 2 comes from the derivative of the inside function. So for the most part, the chain rule, there's a couple ways to write it, but it's basically derivative of the outside. So if you have a composite function, h of x inside of g of x, you do the derivative of the outside, g of x, doing nothing to the inside, and then multiply all that by the derivative of the inside. So in words, derivative of the outside times the derivative of the inside. And there's different notations for it to be written in, either in the dy over dx notation or composite function notation. I'd definitely be paying attention to this notation. So we're going to do the chain rule down here. The outside function is sine, so we do the derivative of the outside function, and then our inside is cosine. Derivative of the outside, derivative of sine, we know is cosine. Do nothing to the inside, so we just bring down what was in the parentheses. Then we have to go ahead and multiply it by the derivative of the inside. Well, the derivative of the inside is cosine. The derivative of that is negative sine. So we get negative sine. Well, we have this parenthesis times this cosine, cosine. So all I'm going to do is just rewrite it, put my negative sign in front, still with my cosine of cosine of x. Notice this is not cosine times cosine. It's cosine of the cosine of x. So it's a cosine in a cosine. This problem here on the right, we need to take the derivative. It's really a function within a function. You should remember that the sine squared of x is really the sine of x all being squared. So now you can see we have an outside function, which is the squaring, and the inside function, which is the sine. So we do the derivative of the outside. We put that square, the 2 in front, decrease the exponent by 1, doing nothing to the inside. Then we got to multiply that by the derivative of the inside. Well, the derivative of sine, you know, is cosine. Well, we could just write this without the parentheses. since it was an exponent of 1. Now, you could maybe leave it like this, but hopefully you remember that this 2 sine x cosine of x is really your double angle uh, sine formula. So that's on your cheat sheet on your calculator cover, so you could simplify it down a little bit. So for the most part, that's the chain rule. So we're going to just try to practice this a little bit more. So whenever you're dealing with a trig function like this with an exponent, I would go ahead and rewrite it where that 5 is your exponent really on the outside of the whole thing. So we have one function that's raising it to the 5th power, and then we have an inner function right here. So we'll go ahead and do the derivative of the outside, putting that 5 down in front, decreasing it by 1, which would be a cosine to the 4th, and then multiplying it by the derivative of the inside. Derivative of cosine is negative sine. Well, now we just have the parentheses times this. We can just write it as a negative sine x cosine to the 4th. So on this one over here, I'm going to go ahead and rewrite this because we're cubing our sine. Oh, that's not what I wanted to do. Just a second. Then we have our sine on the inside. And we have a timesing by 2 on the very inside. So here we really have a function within a function within a function. So we have to do chain rule more than once. So we're going to do the outside. We're going to take the 3, put it down in front, decrease our exponent by 1. So that would be just a squared on their sine. Then we have to do derivative of the inside. So we got to do derivative of the blue. So we're going to do derivative of sine is cosine. Once again, when you're doing chain rule, you don't do anything to the very inside, so that 2x still hangs out. Now we got to do the final chain rule and multiply it by the derivative of the very inside, the 2x, which is a 2. So here I'm going to simplify a little bit. The 2 times the 3 is a 6. Cosine of 2x, sine squared of 2x. The order of the sine and the cosine don't really make a difference because you can multiply in any order you want. So here, we're going to take our derivative. So we'll have to put the exponent in front, decrease the exponent by 1 on this. So if we go 1/2 minus 1, we get this. Multiplied by the derivative of the inside, that would just be a 2. Now in this case, this 2 cancels out your 1/2. So we just get this here. Negative exponent, so we'll toss it into the bottom then. And then if you wanted, you could write it as a root, or you could leave it as a 1/2 power. Would not really make a difference. So on this problem over here on the right, we really have an outside function, raising it to the 5th power. And then we have our inside function, which is the quotient. So if we do the derivative of the red, we put the 5 in front, do nothing to the inside, decrease our exponent by 1. Now we got to do the chain rule, which is derivative of the inside. So we'll do the derivative of the top times the bottom. Now, when we're doing derivative of the top, the derivative of the inside is really derivative of x with respect to x. So chain rule would really be this, which is a special form of 1, so it's not going to change it. Minus the top times the derivative of the bottom. Well, derivative of the bottom is just a 1. Chain rule would be the derivative of the inside, derivative of x with respect to x, so dx over dx. All over the bottom squared. Well, the dx over dx in each case is 1. Timesing by 1 doesn't change it, so it's just an x plus 1, x minus 1 on top. The x's are going to drop. We're left with a 1 plus 1, so we get 2. So now we can go ahead and simplify this. I think I'll go ahead and apply the 4th power to the top and to the bottom here. So now you can see you have an x plus 1 to the 4th on the bottom and an x plus 1 to the 2nd on the bottom. So it's really an x plus 1 to the 6th power on the bottom. 2 times 5 in front is our 10, still with our 1 subtracted from x raised to the fourth power. So this one here has a root. I would probably rewrite that root as a 1/3 power. Then we're dividing. So since we're dividing, I'm going to do the quotient. So derivative of the top times the bottom. So x squared plus 4 to the 1/3 minus the top times the derivative of the bottom. So we've got to put the exponent in front, decrease it by 1. Then chain rule, derivative of the inside, derivative of x squared plus 4 is just a 2x. All over the whole bottom squared. So let's go ahead and do a little bit of simplifying. There's really not much we can do here other than just say we don't have to write the 1. So we'll get that. Now, we could also write the bottom as just an x squared plus 4 all raised to the 2/3 because it's an exponent raised to an exponent. So you can see that down below. Looking here, we have an x, a 1/3, this to the negative 2/3, and this. So my 2x and my x I could put together, and that gives me this 2x squared. And you might be wondering, well, why didn't I pull that or deal with that 1/3? Well, because I want to go ahead and factor. I want to look to see what's the same before and after my subtraction sign. Yeah, that's a bad looking subtraction sign. So now, if I were to leave this 1/3 here, I would have a fraction in the top of a bigger fraction. So I'm going to go ahead and factor out that 1/3. Also, you'll notice that we have an x squared plus 4 here, an x squared plus 4 here, but to different exponents. So, side note, remember, a squared minus a to the 5th. If you were asked to factor that, you'd pull out the smaller of the two exponents. So, we're going to have to pull out the smaller of the two exponents, which would be that x squared plus 4 to that power. So now we want to look at what's left. Well, once again, this red subtraction sign would really be this red subtraction sign. When you look at what's after the red subtraction sign, this 1/3 is taken out. This x squared plus 4 to the negative 2/3 is taken out. So we're really left with that multiplied by 1, timesing by the 1. You won't really have to write it. What's before the subtraction sign? Okay, so think over here on the right. So this 2 plus 3 gives us our 5, right? So you got to think, oh, this times what? We'd have to take this exponent plus this exponent to give us that exponent. So you got to think, negative 2/3 plus what is positive 1/3? Well, that's just that to the first power. Well, if it's to the first power, we don't really have to write it. Okay. But you got to think also our 1/3 here times what is our 1 that we had in front here? Well, 1/3 times 3. So we have that. So looking at this, we could simplify the inside of the square brackets. We could distribute through the 3 if we wanted. And timesing by 1 doesn't change it. This ugly diarrhea color has a negative exponent. That's going to move down to the bottom. This 1/3 is going to cause a 3 to be in the bottom. So we have an x squared plus 4 to a power times an x squared plus 4. So all we have to do is add our exponents, and we just get this. Notice on top, your 3x squared minus your 2x squared is just your normal x squared. So that's our derivative there. Cool, we're done.